You know, when we talk about forestry as a sustainable solution, one of the things that we've heard is forestry is innovative, and people are always surprised at how much I think technology and everything, you know, comes into play in forestry. And so we wanted to ask Curt Rogers and Matt Verley, who have definitely cutting edge technology they've been using, to come and talk for a few minutes, our last session today, and share some of their experience and technology they've been using. So let me introduce, and I'll invite Curt and Matt to come in and bring their cameras on. And Curt Rogers is with Coastline Forestry Consultants. He's an OSU College of Forestry graduate with over 30 years of forestry consulting, and he's accomplished timber cruiser and also designs Access and SQL server databases. And he's worked a lot with Ezra products and since the ArcCAD days of the early 1990s. And Matt Verley of Seaside is a pilot and owner of TimberDrone. And Matt served in the U.S. Navy as nuclear electronics technician. We don't get to say that very often with our forestry announcements. And instructor at Kesselring Prototype Plant in New York. And he's been with the Hamlet Volunteer Fire Department in Seaside for about 16 years. So variety of background and expertise that they bring to this. And so appreciate them joining us for our last session about technology. And we're gonna actually start off talking about technology. We thought we'd throw a poll out there, and Matt and Curt wanted to ask kind of who's using drones in the forest operations and that technology. So if you see that poll should have popped up, or you can hit the poll mark and just have two questions there. The first one, are you currently using drones in your forest operations? Just a yes or no. If you're not using drones in those forest operations, what's your main reason? And a variety of reason, or you can just say I have used drone work and just mark that off again. So be interesting. We'll leave it open here for about a minute and see where people are. But Matt or Curt, do you guys want to give any introduction before we jump into your video?
Sure, I'll start off, Julie. Thanks for the introduction. My name is Matt. Yeah, we ended up, I tried to put something together here and figure out an outline that I could squeeze into 30 minutes and you know, not, and keep up with my visual aids with the videos and screenshots and everything. And I thought that was going to be too difficult. And so what I ended up doing is putting together a Zoom type video, and that way I could really control all the screenshots that came up and the visual aids and everything. So that's actually what we're going to be playing, you know, in lieu of a live conversation here. But it's actually really fast moving. I think people are really going to enjoy watching it. There's no real lulls in there. We really kind of move from one topic to the next in there.
Perfect. Well, we'll look forward to seeing that in a minute. And it looks like the people that have voted are sharing that about 24% of them have used drones or currently using drones, and about 76% have not. So I think this is a big opportunity for them to see what drones can do and what that technology is available in their forest operations. So a variety of reasons that you guys thought that they may be the cost or don't really know about the technology, or other reasons of why they don't use it. So thanks, Matt, look forward to hearing more about it.
Okay, Curt, do you want to say anything, or are we ready to roll the video here?
Well, I would like to comment quickly on that that poll. I was glad to see only 5% don't see a use for it. So we're going to show some pretty good uses, and the more we've been doing this, the more we keep seeing more and more uses. So I think we're still in the infancy of using drones. The technology keeps getting better, the drones get better, the cameras get better. So I think the future is really bright, but this video will do a great job of kind of getting you guys up to speed at what are some of the more cutting edge capabilities of the drones, and Matt's put together a great video, so enjoy.
All right, give me just a second here to get this thing shared.
Hello everyone, my name is Matt Verley and I own TimberDrone Incorporated. And today
Oh, Matt, we might have you restart that. We don't hear your sound, so make sure you check that when you started the share screen. So we aren't hearing the sound of the video.
forestry consultants, and he's a real genius when it comes to database programming and GIS work. And he's really been instrumental in figuring out how to turn the data that we gather in the field into something meaningful for foresters. A little history about me and the company. Now, I'm an instrument-rated private pilot. I have an airplane here at the local Astoria Airport, and I'm also the fire chief on my local volunteer fire department. And TimberDrone is my full-time job. I spend around 20 or 30 hours a week in the field flying drones, and then another 20 hours a week or so in the office doing GIS work and processing photos. Now, TimberDrone's been around for 9 years, and it all started with a social media post and a Christmas gift. Basically, somebody gave me a toy quadcopter for a Christmas gift. I flew it around, had lots of fun with it. I thought, how cool would this thing be with a camera on it? So I took apart a spy pen camera that I had and attached the camera to the drone, posted the video on social media. That video caught Curt Rogers' eye. He thought, being a consulting forester, hey, there's got to be an application for an aerial camera in forestry. So he came over, we talked about it. I started building a couple of drones just so we could figure out how to make them fly autonomously, geotag photos, and we kind of taught ourselves the process for generating ortho photos. And during that time, we obtained permission from a local landowner to fly the drones over their property, and they allowed us to do that just in exchange for giving them all the footage that we gathered. And so for about a 6-month period, we flew the same units over and over and over again, and really refined the orthophoto generation process. We kept logs of every flight and figured out how to most efficiently generate the best orthophoto and how to make the drones produce the most number of acres in a day. So that's a little bit of a history about where we started, where we are now. TimberDrone has several employees, and we also have several we call them partners. They're kind of consulting partners that we work with. And if you'd like to check out our website, timberdrone.com, you'll be able to click on the staff tab and meet each one of the people that are collaborators in TimberDrone. And if you click on our services tab, and there'll be a sub menu in there for forestry. And this page kind of lays out the services that we provide to the forestry industry. There'll be things like harvest unit depletions, where you can use a high resolution orthophoto to delineate harvest unit boundaries. And then at the bottom of the page, we have several sample PDF reports. And these show our autonomous tree counting system. And these do a really good job of providing a visual representation to a forester of how closely trees are spaced together. And we'll get more into that here in just a couple minutes. Okay, we'll start this off by talking just a little bit about what it takes to fly drones legally in a commercial setting. This used to be far more difficult. You used to have to be a licensed aircraft pilot for an actual aircraft in order to fly drones commercially. That's not the case anymore. The FAA has their Part 107 commercial drone licensing program. It's actually not all that difficult. Most people can pass the FAA test with just a couple of days worth of training. The training that's there is pretty basic. It tries to teach drone operators about flying in controlled airspace and the restrictions associated with Part 107. And you can't exceed 400 feet above ground level. You can't go beyond visual line of sight. You can't exceed 55 pounds, and there's some other restrictions there. And so the training is really good. If you guys are thinking about starting up a drone program, definitely don't try and fly under the radar. The Part 107 licensing program is necessary in order to fly legally for a business. And it's got some really good information. It helps integrate drones into the existing airspace. And for a guy like me who flies both, I'm a big supporter of it. I definitely don't want to be flying around in my airplane and see a drone coming right at me through my windscreen. So that's all we're going to talk about as far as Part 107. If you guys have more questions about the licensing program or restrictions associated with flying under Part 107, I'd be happy to talk about it at the end of the presentation. Okay, orthophotos. I've used this word a few times, and for those of you that might not be familiar with an orthophoto, when you take an individual photograph with a camera, that photograph is not dimensionally correct. The features in the center of the photo are much larger than the features at the edges, and so you can't use an individual photo to take measurements. So to create an orthophoto, we pre-programmed the drones back in the office to fly a serpentine pattern at a fixed height above the ground over a target unit. Now the drone will take around 10 photographs per acre that overlap around 80% on all sides. So for a unit, we may end up with, say, 1,000 photographs that we then take back to the office and feed into our software. The software does a few things for us.
Now, first of all, it aligns all the photographs. So it uses the GPS data that each photo is tagged with to roughly place the photographs in space. Because each photograph overlaps each other, the software is then able to identify common tie points around the edges of each photo. So it uses these tie points to further refine the location of each photograph. Once it's got each photograph aligned, then it cuts out all the overlapping area, so we're basically just left with the center, most high resolution part of each photo. Now, simply stitching all these photographs together into a two-dimensional image isn't quite enough. We need to accurately determine each object's position in 3D space in order to accurately measure distances. Now, to do that, the software breaks this down into a giant point cloud, so we get billions and billions of little pixels, and each one of these has its own X, Y, and Z components, so each pixel is located properly in 3D space. You can kind of think of this as a giant jigsaw puzzle that only fits together one way. And it's able to do this because every object is photographed multiple times from multiple different angles. And so the way that an object moves from photograph to photograph relative to the other objects tells the software how high each one of those objects is. And once the software has generated this 3D point cloud, it's able to use that to calculate its own digital elevation model. Now we have this two-dimensional image that's basically draped over the top of this digital elevation model. And we're able to use that to accurately calculate distances between objects. And then we can even take this and put it on its side and use that to calculate heights and even volumes of objects in the photo. Now, once we have this high-resolution orthophoto, we can import that into a GIS program for analysis. Because it's dimensionally correct, we can measure distances between trees, which might help identify understocked areas for interplanting or overstocked areas for future thinning. We also send this through an intelligent tree counting algorithm that analyzes shapes and colors and identifies trees in the unit. And the algorithm does have a couple of limitations, and because it uses colors and shapes to identify trees, it needs to be able to see the trees in the orthophoto. So if you can't see the trees with your own eyes, then the algorithm's not going to be able to pick them out either. And we found that trees need to be at least 3 to 4 feet tall and have some amount of development to them for the AI to actually be able to accurately pick out the trees. The AI is also only accurate to about 700 trees per acre. Once you exceed 700 trees per acre, then it starts to undercount. It assumes it's seeing the same tree once they get spaced too closely together. We haven't found that to be that big of a deal because once you get to 700 trees per acre, it doesn't really matter whether you're at 700 trees or 1,000 trees per acre or 1,200 trees per acre. The treatment's going to be the same. That area obviously needs to be thinned. The AI does need to be trained to differentiate between crop species and non-crop species. You know, an alder tree may look the same as an elderberry bush from the air. So it does take a little bit of effort to train it to differentiate between crop and non-crop species. And right now, we're not at the point to where the AI can differentiate between conifer species. You know, from overhead, most of the conifers look just about the same. And right now, the AI basically just tells us tree or not tree. We don't get different layers for conifers and deciduous trees and things like that. But that is something that we're working on. Now, I've pulled up a PDF report from a job that we completed a few years ago. And if you look in the center of the image, you'll see hundreds of these little tiny black dots. Now, each one of these dots is a tree that's been autonomously counted. And with that, we can calculate the average trees per acre throughout the whole unit. And we're not arriving at this number statistically. We're actually conducting a census and counting every single tree in the entire unit. And this does a really good job of capturing any understocked or overstocked areas. Now, to assist the forester with a visual representation of areas that might deviate from the target tree per acre range, we overlay a 1/4 acre fishnet grid over the entire unit. Now, each one of these squares is a 1/4 acre and it's color coded based on the tree per acre count inside of each square. So if you look at the legend in the lower left-hand corner, you'll see that the squares that contain the target tree per acre range have no color, and they become more green as you exceed the target tree per acre range, and they become more red as you go below it. Now, looking at the box in the top left-hand corner, we have a species breakout here. Now, I mentioned earlier that the algorithm is not able to identify different species. So if the client wants that information, we'll send a person out on foot and put in a handful of plots to gather the species breakout for a particular unit. So our tree per acre number is calculated using the automated tree counting algorithm, but our species information is gathered statistically based on the plots that we've put in. I'd also like to draw your attention to this distribution number. This is a statistic that we've never been able to calculate before, but because we actually know where every single tree is in an entire unit, we can calculate this distribution number, which tells us basically how evenly distributed the trees are throughout a unit. And so if you had a really clumpy unit where you had areas that had maybe 1,000 trees per acre and other areas that had 50 trees per acre, this distribution score would be very low. If you had a perfectly uniform unit that had, say, 11 by 11 spacing throughout the whole unit, you would have a 100% distribution score. And so with this information, a forester is easily able to identify units that might have a wide variation in tree spacing throughout the entire unit. And with all this information merged together inside of ArcGIS, a forester can very accurately get a really good look at an entire unit without worrying about maybe trying to walk through it and missing some areas of concern. So if we look at this area right here that's understocked and we go ahead and turn off the fishnet layer, we can actually see the drone's ortho imagery underneath the fishnet layer and see, hey, did the automated tree counting miss some trees? If not, why is this area understocked? And is there anything I need to do here? Now, one of the really common ways that we utilize our autonomous tree counting system is with pre-commercial thinning operation. This unit here is an excellent example. We flew this one both before the pre-commercial thinning to help the landowner determine if any areas could be excluded. And then we flew it again after to audit the contractor to make sure there was any areas that they hadn't missed. And you can see I have this heat map that we've generated here, and this is based on tree spacing. So the more densely populated an area is, the more red the colors get. And this unit looks like they did a great job. It's pretty much one uniform color, except if you look in the lower right-hand corner, we have these red blotches. And if I turn off the heat map, this correlates to our fishnet grid as well. We can see these areas are colored, and there's just a clump of really dense trees down here. If we turn off all the overlays and just look at the imagery and turn on our tree hits, you can clearly see that this area simply was not properly thinned. And then if we pan throughout the rest of the unit here, we can look both at before pre-commercial thinning or pre-commercial thinning imagery and also the imagery that we gathered after. And once we've analyzed these units inside of ArcGIS, the data that we've gathered can be used to generate georeferenced PDF reports for each unit. And a forester can look at this information subjectively as well by looking at both before and after imagery. For locations where the automated tree counting doesn't work well or doesn't make sense, the drone imagery is of high enough resolution that we can put in 50th acre virtual plots and count the trees inside the plot and obtain our trees per acre number using this alternative method. Now, when we do one of these jobs that contains dozens or maybe even hundreds of units, we need a way to maximize the accessibility to all this information rather than just a folder full of PDF reports and a bunch of GIS layers. And so we've come up with an access database that conveniently groups everything together and allows you to filter and search based on a number of parameters. Now in the sample database we have about 7 units, and as you can see, all the same information is available here as what's available in the individual PDF reports. We have unit location information, average trees per acre based on height and species, our distribution score, and then the fishnet, color-coded fishnet grid map at the bottom. Now this button here allows you to print the report, so you can print the information that you're seeing here. And we also attach the actual PDF report to each one of these so those can be easily accessed from within the database. Now under the report section of the database, we have all of our units conveniently grouped together in one location, and we can sort them based on any of the data that's included, such as the region or the number of trees per acre. Over here we have our filters tab, and we can use this to filter units out based on any of the data that's included. So for example, we could filter out all the units that have above, say, 350 trees per acre and only view the remaining units. Now this reports button allows us to generate a report based on all the filters that we've just applied. And so the user can print this report right here of all the units that he or she wants to focus on. Well, for projects that don't require measurements, where we don't need an orthorectified image or georeferenced image, we found 360-degree spherical panoramas to be useful. The spherical panoramas are taken with the drone. The drone's flown to a target location, and then we run a script on it. And the drone remains stationary, but it rotates 360 degrees and moves its camera gimbal in all directions. It snaps about 30 photographs that we take back to the office and then stitch into this spherical panorama. Once the panorama is created, any viewer can load this into their phone or tablet and actually grab the tablet and move it in any direction and change their field of view to that direction. You can zoom in and zoom out, and there's a lot of detail that's visible inside these panoramas because the drone's very close to the ground. Now for this project, a client had us use our spherical panoramas for vegetation control verification. They had us fly to some key locations in the unit and capture the spherical panoramas. We took these back to the office and placed the locations inside of the unit boundary map in ArcGIS. And using the hyperlink tool, the landowner is able to click on any one of these locations and instantly be taken to the panorama viewer for each location, where he can view the unit from the drone's perspective. Now, post-harvest unit depletion imagery, fifth-year inventory, and pre- and post-pre-commercial thinning operations and autonomous tree counting really are the bulk of what we do here at TimberDrone. However, we do have several other uses for drones in the timber industry, both projects that we've completed in the past and some that we have ongoing right now. So we're going to move into those. I'm going to show you a couple of the more interesting drone projects that we have going on. Now, first up is going to be a drone that we custom built a few years ago, and we've used this drone for heavy lift operations, both carrying equipment and emergency operations. And I've got a short video clip here of it carrying some gear to the top of the Astoria column. And we've also found use for it in replanting operations in ferrying seedling bags over particularly rough terrain. And I've got a short video clip here of a seedling ferrying operation that we conducted earlier this year. The drop location for the seedlings in this video is about 1,000 feet from the landing where it's being filmed, and the turnaround time is about 1 minute and 30 seconds. That's a round trip for the drone for each bag drop. One of the other things that we're using drones for here at TimberDrone is post-fire mapping. Now, the 2020 fire season was pretty significant. There was quite a few fires that burned here in the Northwest, and unfortunately many of our clients were impacted in some way by a fire. And several of those clients have asked us to map fire boundaries. Now, using drones for post-fire mapping has some advantages and some disadvantages. The ortho photos we create with a drone are roughly 1-inch resolution. Now, that's significantly better than fixed-wing or satellite-based alternatives. The drones can also fly in most weather conditions. As long as we don't have heavy rain and the cloud ceiling's above about 1,000 feet, then we can send the drone up to gather imagery. We've also been able to successfully use our thermal imaging drone for a couple of fires here on the North Oregon coast. Now, the first clip I'm going to show is where the Cannon Beach Fire Department called us and asked for help in locating reported fire. Several bystanders had reported seeing and smelling smoke in the area, but no one could actually see where the fire was originated. So the fire department called us, and we sent up our thermal imaging drone, and as soon as the drone got about 200 feet in the air, just directly overhead, I was able to instantly spot the fire with both the thermal camera and the visual camera. And this gave me the ability to send the latitude and longitude, both thermal imagery, video and photos, and also visual photos and video to the ODF crews on the ground. This was a great help in giving them an estimated size of the fire and really helped them plan what equipment they needed to pack up to the area because it was very difficult to reach on foot. Now in this next clip, we send our thermal imaging drone up over a slash pile that had burned several months prior. Now, there'd been several rainstorms moved through, and that area had received around 10 inches of rain in the previous month. And from the landing, there was no indication that there was activity left in the pile. No smell, no smoke, or anything else. But sending the drone up told a different story. Well, this concludes our presentation. I hope you find some use in the information that was presented. And if you'd like any further information or to send us a note, please visit our website at timberdrone.com. Thanks.
Well, thanks, Matt and Curt. That was a really informational, a lot of good technology ideas. I think we have a question that came in. How large is the tree planting drone? Do you need a different license to operate it if over 55 pounds?
Yeah, so the tree planting drone itself weighs in at about just over 20 pounds, which means that I can carry just over 30 pounds in a tree bag without exceeding the 55-pound weight limit. And so yes, under Part 107, you have to be under 55 pounds. So I bring a fish scale out whenever we do that and weigh each bag. And if it puts the gross weight over 55 pounds, then we just don't carry those bags. It is possible to exceed the 55-pound limit. And I don't know if it showed up in the video, but the drone actually has a tail number. And so if necessary, it's possible for us to get permission to exceed the 55 pounds. However, you can't do that as a Part 107 pilot. You have to fly it essentially as an actual aircraft. So it has to be a licensed, real aircraft pilot to fly it.
Great. So someone's wondering, would TimberDrone infrared sensors be useful for search and rescue operations and detecting human beings that often, might be lost in the woods?
Yeah, so I, as the fire chief from the fire department, I do have a good working relationship with other fire departments and the sheriff's department in Clatsop County here. And we've been called to help with that a couple times. The resolution on the thermal cameras on the drone is not as good as what you would find on like a police helicopter in Los Angeles. It does work for spotting, animals and people in the woods. However, there needs to be a sizable temperature difference. So if we're looking for someone that's been in the woods for 2 weeks and is hypothermic and everything, it's going to have a really hard time picking them out. If the police are looking for a fugitive who's sprinting through the woods and, really hot, then yeah, it works great. You can see through the tree canopy almost and, see them almost wherever they are. I think as time goes on, the thermal imagers are going to get better and that's going to work better. But right now, if I searched an area for someone that was missing, there's no way that I could definitively say, well, I've searched this area, they definitely aren't there. It's really just kind of an aid to assist, not a tool that, that we can rely on with 100% accuracy.
Sure. Have you done herbicide applications with any of the technology?
I have, with that big drone that we have, I had a 7-gallon tank for that and a spray boom. I've sprayed, I don't know how many hundreds of gallons of blue dye through it, but not one drop of actual herbicide. And I don't have a background in herbicide application. It was more of an experiment to see if we could make it work. And at least to the best of my knowledge right now, I don't believe anyone in Oregon has been able to do that yet. I don't think that you can get an applicator's license in Oregon using drones. I know in Washington, I believe Drone Seed and maybe a couple other companies have actually done that, but that's beyond actually spraying some dye and doing a proof of concept. We haven't pursued anything beyond that.
And then, do you guys take jobs all over? It looks like you're in the Seaside Astoria area, but how far reaching have you guys been?
So we've worked all the way from the Canadian border all the way down into Northern California and over in Eastern Oregon. I do have an airplane here at the airport, and actually it's in Kansas at the moment, but normally it's here. And so that means that for, I mean, we can get to anywhere pretty much in the Northwest pretty quickly.
Great. Well, thanks, Matt and Curt. Appreciate you guys coming on with us, and great information and resources for people to think about as they think of how to incorporate more technology into their forestry operations. So appreciate your time with us today.
Can I mention one thing?
Oh, sure. Go ahead, Curt.
Yeah, well, I sort of answered Margaret Banks' question, but I more pushed it off to Matt. So I want to give Matt a chance to answer the question. Her question was, are there new federal drone regulations coming that will restrict flights to areas with constant connection to satellites for live flight location? If passed, wouldn't that restrict drone usage on a lot of timberland? And I know we've spoken about that, but I think you stay more on top of that than I do.
Yeah, so if you do a Google search for the FAA's remote ID proposal, that'll bring up tons of information. And basically what that does is it tries to integrate drones into the FAA's airspace system. So drones would as soon as they're airborne, they would broadcast their GPS location, and they would actually show up on air traffic controllers' radar screens. And starting in 2020, all airplanes had to have a similar system installed. So they're not relying on radar hits to show the airplane's location. They're actually broadcasting their GPS location. And the remote ID proposal would integrate drones into that system. And obviously, in order to send that information somewhere, you would need to have some kind of internet connection, and the cellular network makes sense to use that. And the concern is that the FAA hadn't really taken into account the fact that some of us fly drones out in the woods where there's no cell service. I personally wrote a letter, and I know about 40,000 other people sent letters to the FAA saying, hey, at least take this into consideration. A lot of us fly drones where there's no cell service. There is ways around it. Personally, if the FAA comes out with this remote ID rule and restricts us from flying in the woods, my plan is to simply pay for satellite-based internet so I can retain an internet connection wherever I am, because I can't stop flying the drones out in the woods. I do think, though, that based on how the FAA's done this kind of thing in the past, I'm sure that they're going to have a waiver system in place that'll allow people to fly where there's no data connection.
Well, certainly appreciate your guys' insight on that. And if people have more questions about that, it sounds like you guys are the right guys to call and get more information. So appreciate, again, all your time today.